Okay. Is it working? Okay, I can hear myself on YouTube. The music isn't coming through twice. Or it's not coming through on YouTube at all, which is what I want. Okay. I'm gonna mute my YouTube because I think that audio is working okay. Also, Standard CL, you got first. Welcome in. Okay. Thanks for checking that in. Yeah, there are like latency settings for how much delay you want, but it compromises the quality, I guess. There's like ultra low, low, and normal. Ultra low being the least delay, but I'm not sure what the impact on quality is. Hey, Stookie. It was surprisingly easy. Like I had to mess around with like a couple of the settings, but just to get something on YouTube, it was not a big deal. Teensy bit blurry, not sure if it's on your end. Oh. I'm streaming up to 10. Actually, let me open up my YouTube thing. I'm sorry, it's going to be a second before I get into the actual math. I want to make sure my stream is going okay. Man, I need to fix my my chat window because I'm logged into my gaming YouTube right now. On the chat that I have in OBS. View your channel. Yeah, I guess I should actually look at how the video looks. Oops. Okay, I'm in HD 1080. Yeah, the video could be better. You're right. It seems readable enough for me for now, but I did notice my bitrate has actually been on 6,000 the entire time that I've been streaming, and I probably need to up it. That's probably the first thing that I try, but yeah, the settings for YouTube seem like you can bump the bitrate up super high if you wanted. That's not a huge point in doing it. In the actual encoders you can use are way better than what Twitch has, so I need to look into that more. It's a little bit limited though when so you have to like one primary thing you stream to, and then like the way that I set up, so you like a primary and then like the secondary, and the secondary is YouTube. You don't have as much control over that secondary one, but well, you can. You just have to kind of like finagle with it. But for now, I think nothing tragic is happening with the YouTube stream, so I'm going to try getting into the math. Or I'm going to attempt to. So the only DM that I've had from the last time I streamed is this person just asking for someone to verify their understanding or the definitions that they wrote for triangle congruence with side, angle, 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 side. Their handwriting is actually really good. They kept apologizing for it, but like it's better than mine. I was having a hard time like understanding the actual words, like, or the actual like sentence that they had for angle, angle, side, but I think it was right. Sentence? Sentence. There we go. Just gotta sound it out. It all looks good. Okay. Let's go look for new questions now. definitely flickering between blurry and perfect, so this might just be me. I should compare it maybe with how it looks on Twitch, because the text, definitely you could see the rough edges to it, and I think you see the rough edges on the whiteboard. It being at an angle doesn't help. I was really struggling to get the whiteboard angled straight on. Let me open my Twitch stream and just like compare it quick. Because if Twitch is the same, then it's definitely just my bitrate, and it's not YouTube's fault. Twitch seems sort of similar, and I'm also, dude, my desk, I need to get a better mount for my camera. It's shaking a lot when I actually have it on full screen. I can't tell just in my OBS preview. Hey, Tiny Leopard. Yeah, welcome in. This is my first YouTube stream ever, so hopefully it's not too bad. But yeah, I know stream over on Twitch, but I thought I'd try out you know, simul streaming or multi-streaming today to see if people on YouTube would be interested. So thanks very, very much for coming by. First time seeing it. Oh, cool. So yeah, there's a pretty active community over on Twitch. I haven't researched it for YouTube, to be honest. But yeah, my whole shtick is I prefer to take questions from chat, like people actually are asking me for help in particular, and I have a whole like the Discord server to do it too, if that's easier for people. But in the meantime, if I can't find questions, then I look around on the internet. So like right now I'm looking on Reddit. There's like a Discord server that I'll look in. I'll occasionally venture into other websites too, but they get kind of sketchy, so I tend not to. Okay, so I don't see much on the subreddit. I could have scrolled down further, but I haven't found much on there for a very long time, unfortunately. Fifth year. Is that fifth grade or like fifth year undergrad? Could be interpreted. I assume that's like an undergrad thing or something, but or PhD maybe. You know, those take 5 years, right? The answer is root G. Oh, well, which question is it? 19. Okay. Particles moving on the inside smooth surface of a fixed hollow sphere. The internal radius of the sphere is 2 meters, and the particle is describing Excuse me? If the inside radius of the sphere is 2 meters, is the particle floating in the air as it moves at root 3 meters? I'm having trouble even visualizing this. Maybe let's look at their work and see if that helps. And oh, maybe I should have zoomed in, because it's readable for me, but it might not be as readable on stream. That doesn't really help that much, does it? But let's just look at their work. I'm even more confused. Why? I mean, I'm not like doubting the person. I'm just confused by the wording of the question. Internal radius of the sphere is 2 meters, describing a horizontal circle of radius root 3. Root 3 is less than 2, last I checked. Calculate the angular I don't get, like, the particle is floating in the air is my interpretation, moving in a circle inside the sphere, and why is the sphere even relevant then? But it's not, wouldn't be on the surface. Because how do you possibly make a horizontal circle of radius root 3 and you have a sphere of radius 2? Maybe this is the key. Oh, maybe that's like the instantaneous velocity. Like it's currently on the surface, but it's about to fly off? What I mean, the particle's describing, maybe is describing means something particular that I'm not familiar with. Calculate the angular velocity. Wait. I hope they're not saying the hypotenuse is root 2. They do get root 6 over there. This is a little bit too physicsy for me, I think. Unfortunately. My physics is a little bit too rusty for those. Because I'm really confused on the wording of the question. I'm sure it makes sense if I knew the terms better. Let's just move on and look for a different one. I don't feel more confident answering. Okay, they try to do this with integrals. They can't seem to forward. Oh gosh. Ooh, this is okay, this is calculus-based stats. This is the PDF. Can someone help me solve this? Ask about the entire question, I guess. So I assume they don't need help graphing. So they're saying they tried doing with integrals. Yeah, you'd integrate it. It's weird that the measurement error isn't like symmetrically between the, or isn't symmetric between the positive and the negative part, but I assume it's just, you know, quality of the scale. What's the probability? In 0 is no error. So I think you just integrate 1/2 from minus 0.5 to positive 0.5. I don't see what's wrong with that. Will exceed 0.75. The absolute value of x is greater than 0.75, but in this case, our function is always positive, so that shouldn't matter. So someone else already started on this, but I'm going to jump in here. Okay, let's see if they reply after that. They just kind of posted the problem without showing their attempt. So I'd like to hear a bit more about what part they don't understand. A scat test? Is that SAT that's a typo, or is there actually something called the scat test? Like... Okay, I was curious to see. There is this answer, so I'm going to move on, but I just want to see what a scat test involved. Yeah, Leopard. Because I mean, I don't know if that person in particular would do it, but there are some people who will just like basically try to get you to do their homework for them, one problem at a time. Which I don't normally mind showing someone the answer once, but if they want to, if they ask a question and I tell them how to do it, and then they ask another question that's basically the same type, then I want to hear more. So sometimes for posts like that, I do just say the answer, but depending on how they ask in my mood, I guess. Often I try to get them to figure out what part they don't understand. This looks complicated. Trig to help with. We have a physics problem, a stats problem, even an econ problem. Oh yeah, this sub is pretty active. It's homework. The subreddit is just homework help. So you get things like social studies or English stuff coming in too. Although usually the math and science subjects are people are more commonly in need of help with. And some people post like Spanish questions too, or like you know, like languages. What is happening here? Is this the same as this? I feel like they haven't posted the entire question here. I'm gonna move on because I feel like I don't know what's happening here. Oh, it's collage math, not college math. My bad. That's probably why I don't know it. I shouldn't make fun of people for making typos because I make typos all the time. But they also just I laugh at other people's typos and I laugh at my own typos, I guess, because sometimes they're funny. Galaner got this one. This one has answers as well. Dang it, Alkalaner has cleaned out this subreddit. Okay, here's one that doesn't have an answer. Define degree and order of a differential equation. Solve the differential equation. Oh no. Oh no. Degree of a differential equation. I know the order of the differential equation is the highest derivative, so this would be first order. What is the degree of a differential equation? Before I even think about trying to solve it. This isn't linear. It's not separable. Is there an identity for that sign? Even then, if there's an identity, a product identity for sine inside? No. Or it's just, maybe it's too big for this chart. Hmm. This does not seem easy to solve. Because this is saying the degree is... Wait, oh. The degree is the same thing as for a polynomial. So this thing is degree... second degree. Power to which the highest order derivative. Oh, okay. So in this example, the highest order is 3, so you take its power of 2, so it's second order. Or second degree. Third order, second degree. And over here, it's first order, first degree. Well, I doubt that's the part that they need help with, unless I'm caught up on the first part of the question. Okay, okay, before I get too deep into that, let's go back to this stats one. This should hopefully be a quick response. Oh, Aquiliner got right on this one, wow. So no, if you do the limit from -0.8 to 1.2, you should get 1, because that's the definition of a PDF. Let's actually do that little experiment to make sure that I'm remembering this right. -0.8. So, you know, I'm sure if you're good at mental math, you could just tell, but I'm not. 1.2. 1/2. So if my calculations are correct, this should be 1. Okay, yes, it is. But what that person needs to do is basically the problem kind of gives them the bounds. So you got a 50-50 shot of being with... Can you just figure that out? Because they give you a really convenient function. The entire length is 2, and they ask you to find the length of an interval of length 1. So that actually makes sense that you get 0.5. This is just a uniform distribution. I'm still going to add in my own answer here. I'm kind of butting in, but I have a different way that I want to explain it than this, so hopefully one of our explanations will work for this person. Well, I don't say the entire domain. The entire interval. You'll just get 1. And Zach, thank you so much for the raid. Happy 1 year. Thank you. Yeah, it's for anyone who doesn't know, today is the 1 year mark that I've been streaming. Thank you too, Dan. For the people on YouTube, I just got a raid on Twitch from Zach, aka E to the 2i pi. Why isn't Nightbot? Okay, there we go. Let me get the link over there in YouTube too. And since there is the YouTube audience here, Zach is teaching a real analysis class live on Twitch right now. So yeah, I'm trying it, Zach. This is my first time, so it seems to be going slightly okay for now. But if you're interested in learning real analysis live on Twitch, I highly recommend you head over to Zach's channel. There'll be another session of it in 5 hours from now, whatever that is in your time zone. Let me see. And Stuki, thank you too. And Obi, hey. 15 minutes late. Oh, it's starting apparently in 5 hours and 15 minutes. It's going to be 15 minutes late. Or I'm misinterpreting things that are being said, but later on Thursday. Oh, okay. So scratch what I said. It will be in 5 hours. be between minus 0.5 and 0.5. And you're integrating over x already anyway. Okay. Hopefully this is enough of a kind of lead for this person. For anyone who's just joining, I was helping out, or I was responding to this one person's calculus-based stats question. And it seemed like they're given just like a uniform distribution here, and I was trying to get them through part B at least, and then part C will follow a similar flow. Swedyan, if I'm saying that right, thanks for the follow. Okay. So that's something that I was kind of in the middle of applying to, and in the meantime, I was working on this other differential equation one that looks kind of mean. So I just learned what the order of a differential equation is. I knew what the degree was, but I hadn't heard of order. But to actually solve this thing does not look easy. I wonder if there's some kind of change of variables that you need, or something. She could stay. No worries at all, Zach. I hope your meeting goes well. See you around. It's required. Oh, okay. Well, I hope it's not too boring. You know what? If I had to moderate my YouTube chat, how would I? Oh, if I hover over it, there's like ... dots. Huh. Probably should have figured that out before I went live, but I'm sure it'll be fine. How are those have sync their chats? So right now I have two separate chat windows. The thing about Twitch has a rule that you're not allowed to show combined chats on stream if you're multi-streaming. So the chat window up there is only Twitch. And it's hard for, I mean, it'll be hard for Twitch to enforce if you wanted to risk something, but I don't want to risk anything, so I'm just gonna not post the YouTube chat, I guess, unless they change that rule, or maybe I'll change how I stream. Hey, Enders. And thank you. So I don't know if I can do this differential equation. Let me just kind of take a little look at Paul's notes and see if there's anything that rings a bell. I'll need to like verify it after the stream, but YouTube also shouldn't be hearing the music, unfortunately, and they also shouldn't be hearing the Twitch alerts, which I should get YouTube alerts. So I'm going to be doing this more, but I'll work on it later. Okay. There's no way I can make it an exact equation. No, there's no way. If you divide by y, there's an awful lot of x's over y's. That's true. Oh, okay. And then we can say like u equals x over y, and then we just have, no. Yes? Yeah, we have to figure the dy by dx. Okay, that's a, okay. Yeah, I think you figured it out. It is a change of variables. I just didn't see that manipulation to do first. For EB. It's a team effort, I guess. Why isn't my hotkey working? OBS, I've given you a command. Hide my webcam. Wait, why? Did my hotkey get broken? It's still on control numpad 8. Oh, wait. It got broken. Oh my god. Okay. I'm talking my webcam manually. No, I tried numlock. Your OBS has some regularity. Oh, okay. I figure it's because I just installed the plugin to let you multi-stream, so I assume that's what messed it up. I'll look into it more after the stream, though. I can just manually hit the little I symbol. It's not too much of a pain, so I'm not like playing a game or anything like that. So we have x dy dx equals y plus x sine y over x. And so if we follow Stupi's suggestion here, divide everything by y, because we don't allow y equals 0, but who cares? Dy dx is equal to 1 plus x over y. This is okay, right? Yeah. Because we can always do like a -1 power. So let's say u equals... I'm going to say maybe y over x, so the thing inside the sign is simpler. I don't know if it's a good idea or a bad idea, but let's just try it with this, I guess. So we do need to solve this, or we do need to figure out dy by dx here. Sin x over y. Oh, I copied it down wrong. Okay, thank you. And Cletus, welcome in. Okay, so if we say u equals x over y, and then we do d by dx of both sides, knowing that y is a function of x. Let me do this in a second line. This is the part of substitution that always kind of trip me up if I have to do it like freely, I guess, or like, you know, without the guide of like integration or something. So I hope I'm doing this right. So on the left side, we just get du by dx. On the right side, I guess we quotient rule this for lack of a, well, I guess, yeah, should we quotient rule or product rule? Even better news? Oh yeah, for sin x over y. I guess let's quotient rule. So we derive the numerator first. We get a dy by dx minus derivative denominator. No, I'm sorry. We derive the numerator, so it's just y. I probably shouldn't mix my notation. I wrote the y of x to remind me that y is a function of x, but let's not mix notation too much. Okay, minus derivative, or just the numerator times the derivative of the denominator, dy dx over that doesn't look simple to solve. For dy by dx. Well, if we multiply both sides by y, would that be simpler? Before I even tried to derive each side? Because now if we do d by dx, hopefully we don't get like multiple dy by dx's. Now this is just a product rule there. Du dxy plus dy dxu equals 1. And so now dy dx is equal to 1 minus du dx over u? And I guess that's okay. Oh yeah, and we will get a cancellation over u times u. Okay, this might work out. Let's keep following this train of thought. So now we'll sub on this equation here with u equals x over y and dy by dx equals 1 minus du dx over u. So then u, because x over y equals u, times this thing over u is equal to 1 plus u, not me, but u, times sine u. Okay. So the u's cancel there and there. The 1's are going to cancel. dy dx. So we do u, cancel u, 1, or minus 1, minus 1. So multiply by minus 1. And now, oops, that's not you. That's not y, that's u. Wait. Yeah, that's you. Oops. I was wondering why that wasn't working out. Okay. So I want to solve this u with an integrating factor. You could divide each side by u sine u and separate variables, but integrating 1 over u sine u doesn't look fun. So the integrating factor mu, I think, is e to the integral of sine of u. But I always get this part mixed up. So let me, I know I'm messing up my browser right now, but just bear with me for a second. So I just need to remind myself what the integrating factor actually is, and then I'll fix it. U of t is e to the integral p of t, and p is the function that goes with y. Okay, good. Oh wait, if it's homogeneous, does that formula even work? Would we need to be equal to 1 for this to work? Maybe this isn't much easier either. It should work if it's homogeneous. But I'm getting mixed up because in the formula here, you do have to end up integrating u of t times g of t, but our g of t is 0. So we end up with just 0 as our solution. That's not right. Get rid of u gets us a sine function down. Right, the same thing we just had times sine. So, oh, is the solution? Oh, it's just e to the sine, or e to the minus cosine. It's maybe a combination of both. But just think about this more intuitively, I think is what Obi is saying. Oh shoot, webcam. Think about, like, I guess this step more intuitively. What function can you derive to get itself back times the negative sine of that? Well, it's sine of u, though. It'd have to be something like... Oh, Dr. Gold, hey. Sine into exponents. Like with imaginaries? I'm sure it works, just going into imaginary numbers always kind of scares me. Enigma, thank you. What does Wolfram Alpha think of this? Separate variables? Well, how do you integrate u over sine u, though? Or 1 over u sine u, at least. That's what I was struggling with. Try and get it so that the browser's only in like half of it, if I can. So the problem is still somewhat visible. If I just give it the differential equation, I wonder if it'll know how to solve it. And I'm going to do y's and x's instead of u's and x's. Actually, am I going to interpret that right? Okay, yeah, it looks like it's interpreting that right. You get imaginary. Oh no, that's the alternate form. I think that's what actual education was saying. Oh. I don't think Wolfram Alpha knows how to do it. These are just like numerical things. Unless the sample solution means something that I'm not aware of, which I don't know what it means. Felix, yeah. Cletus, we have 1 over that if we separated variables. So you have to integrate 1 over x sine x, and I don't know what the heck that is. We could try giving that to Wolfram Alpha too. I assume it's nothing pretty though. Not even Wolfram Alpha wants to do that one. So I think we can at least post what we've tried here. It might help this person out. Anyway, even if we can't get to the end, I think this must be what you have to do, I think. I just don't really know the technique from here. Your TI 89? Well, no, did you do 1 over x sine x, or did you do x sine x? Because x sine x is a relatively simple integral. I don't think that's right, Cletus. No, I think you need to put the x sine x in parentheses. Because I think it's interpreting it as 1 over x times sine of x, and the sine of x is off to the side for the way the TI might be interpreting it. Or maybe not, but I mean, if we really want to be careful, we could derive what you said back, and I assume it's not going to be the same thing as what we put in. You get sine x minus cosine x, and if we derived what you got, we would expect to see 1 over x sine x. So unless it's somehow like there's some crazy, identities involved here. I do really appreciate you like helping investigate this though. I don't mean to just say negative things about your thoughts, but I don't think it's I don't think that's quite right. I appreciate it. a certain part when trying to, hey Felix. For what? For integrating 1 over x sine x? There's no way that's the answer. Oh, I'm sorry. So that was just... Because I think that's what... The actual problem that we were trying to integrate was 1 over x sine x. Because people were getting confused about whether it was 1 over x sine x or just x sine x. So I was just showing why it is 1 over x sine x, and that just x sine x isn't what we're working on. Really? I mean, that looks complicated enough that it might be right. Hey, Bookbinder, can you solve integration problems? I can sure try. There's some hard integrals that I have trouble with, but if you're just in like a calculus class, then yeah, I can definitely do it. Feel free to type it in chat. I have a Discord as well. I really should have the link ready. This is my first time ever streaming on YouTube, so I need to set up a chat bot and stuff. But you can type the problem right there in chat, or you can put it in my Discord. And that is me right there. I'm just oh my god. There we go. That's me. I'm logged into the wrong account in my little OBS preview. And I don't know how to fix it. And Shuman Nahata, welcome in. I do not know chemistry, I'm sorry. Sometimes there's people in the community who will know the answer to that. If you want to try posting your question, I'll like put it out to the community. But I'm not good with chemistry at all. You're from India? Oh, hey, that's awesome. Well, welcome in. Basis, how much do you rate yourself on the basis of maths out of 10? That's a really broad question. I would give myself like a 3. The more I know, the more I know what I don't know. I have a bachelor's in applied math. It's probably a better way to measure my skill level, I think. Rather than some arbitrary. Felix, is this what you typed, or did I do something bad? Oh, I don't need that 2 there. Also, hi, Jed. I didn't say that. Oh, it's horrifying. Oh, no, Wolfram. Well, I'm trying to verify the integral that you got. Okay, let me... So, Felix, let me just back up all the way. The situation we were in is we had this differential equation, we did a change of variables, we ended up with this differential equation or that. And so we were seeing if you could divide each side by u sine u and do separation of variables and integrate each side. But who the heck knows what the integral of 1 over u sine u is? That's a problem that we were working on. And so people were getting in the weeds with 1 over x sine x versus x sine x. which is I root 3 over 2. How is India according to me? I don't have an issue with it. I don't know. I don't know if you're looking. I don't quite know what you're looking for with that question, but do you know about Ram Mandir? No, I can't say I do. Okay, so even though I've gotten sick, I think I have something to contribute to this person's question, even though I wasn't able to solve it. I think this is the right first step. Anshuman, I'll Google it quickly, but not Ramanujan. Does this have anything to do with math, Anshuman? It just looks like Google saying it's a Hindu temple, Ram Mandir, which it looks incredible. Okay, so I attend a math focus for the stream, but that temple does look great. Bookbinder, how much hours do you study? A day? I only really study what I stream, I guess. Plus, a real analysis class is being taught by Itza2iPi on Twitch. So I guess if you average it out, 1 to 2 hours a day, but how much you should study a day kind of depends on your goals and what you're currently doing. Everything by Y. That, then we're left with many x over y's in the equation. And can do a u equals x over y substitution. I'm in California, and Shimon. In America. Oh, see ya, Bookbinder. Thanks for coming by. Both literally. Yeah. You know, Jed, since you just typed in YouTube, is there a way that I can like mod you even though you have no obligation to actually mod? I don't see how you actually do that. Maybe I should figure it out later. Wait, mod. Oh, that's how I get the mod controls. Moderation activity will be shown. Oh, hey. I'm sure. Oh yeah, or I mean, I'll only mod you if you want to be modded, I guess. But I did just figure out how. And you wouldn't be obligated to do anything with it at all. Just if you wanted it. Modiji? I'd never heard of that either. And Marcin, hey, welcome in. Thank you so much for the kind words, Bookbinder. Hope you have a good day. Oh, and Antoine, that's fair enough, but I don't want to bring politics into this, if you don't mind. I just want to talk about math. That's fair enough, Anshuman. I just ask that you keep it to yourself. This isn't the place to... You're welcome to think whatever you want. I just don't want someone who maybe disagrees to start up an argument, because this isn't the place for it. Oh gosh. Yeah, chat. Person whose name I can't pronounce, I'm like 50% sure that that's two. I think we still need mathematicians to verify that. All right, Jed, I added you as a mod. Well, you of course don't have to do anything with it, but... You know, apparently I have 8 people over on YouTube, so thanks to everyone who is here on YouTube. This is my first ever YouTube stream, so I'm still kind of learning things. Okay. How much do you earn? Very little. I'm a small streamer. This is more of a hobby. It's something that I would love to turn into a job, but it's very much still a long shot, and I'm being realistic about that. Since I don't see better, since there isn't a response at all right now. Okay. Hopefully that just gets the person started. And they can see a step that I didn't see. Let's actually check back in on this thread. Okay, this person hasn't responded. Let's close out of it. Okay, so one has an answer. Oh yeah, Leopard. I've been streaming for actually a year ago today. When I first started the stream, I didn't realize how rusty I was on math, because I graduated, or I got my bachelor's in 5 years ago, whatever that was, coming up on 6, I think. and I forgot a lot of it, and having to like do such varied questions really helped me remember a good amount of it. There's still a lot more that I need to relearn. You have oral thesis defense in 2 days? Geez, good luck, Felix. What is your thesis on? Yeah, to everyone who's new to the stream, there's definitely some slow parts of the stream where I'm just like kind of trying to look for questions. So I hope you guys don't mind just kind of chilling in the meantime. I do my best to find questions, but sometimes it's just there's hard to find ones that someone else hasn't already helped with in that I can know how to do. So I have been posting my VODs onto this YouTube channel and just like cutting out these bits, but obviously with the live stream I can't, so. Okay. Can you maybe explain how to read the logarithmic scales? Yes, and also welcome in, Min. Let me look up like kind of a visual aid here. I don't know if Wikipedia's gonna be the best thing to look at. So it's kind of a contextual thing, I guess, for how, because like or like logarithmic scales can come up in many different contexts. So it's, you know, maybe there's some like context-dependent things that might help like you to do it in your specific application. Oh, thank you, Jed. I probably prefer that. But basic thing to remember is that like each horizontal, in this specific example, the y-axis is kind of the logarithmic part of this. And so each of these bars are not equal, or at least they're powers rather than kind of even increments. Like along the x-axis, the horizontal one, it's just every tick mark is 4 years. But here you go up by 900, 9,000, or, you know, that's actually a bad thing to say. Like, you know, 1,000, 10,000, you add on a 0 each time. It's another power of 10. So even though it looks like this kind of smooth curve line-ish thing, and the scale, it might look, if you were to make this scale on the left of the linear, it might have a completely different shape where it goes like, you know, to the right and then up or something like that. And I think the Jed that link provided, the link that Jed provided, usually has much simpler explanations. Oh, it's a little bit short. I wish I actually provided a chart. But this is kind of like the compacted version I was just trying to explain, where a linear scale, everything is evenly spaced. In a logarithmic scale, things kind of get more compressed. Or, you know, you're taking the same amount of space and you're just like compressing it more and more the further you go. In the same way that back on this Wikipedia page, it's almost like the opposite, where you're checking the map. Okay. You know, sorry, because if I prepared, I'd be able to give a much like better explanation, which is why I'm kind of like. Actually, that's my excuse at least, but. It's something where like I'm trying to think of the best explanation on the fly, so I'm sorry that I'm not explaining it better immediately. More or less, Jed, yeah. It's So like in this example here with the logarithmic scale, for the same amount of space, you're including way more numbers. It's like you're playing with the spacing of the graph itself. Like if, let me actually maybe even draw this. Because I do really like the example that you just linked me there, Jed. So just ignore the stuff on the left half of the board. So kind of what that link showed was an example of basically a logarithmic shape or an exponential shape, something like that. And I'm going to draw just like horizontal bars across here that are about evenly spaced. Actually, maybe that's bad. Sorry, it's a part of me just like building the plane as I'm flying it. Okay, and I'm just thinking for a second. Up 10 to the x. Yeah, Felix, so I like I'm thinking like maybe a different angle to explain this is if we take this as like an exponential curve, like I think Felix shows a good example here. If we pretend that's like 10 to the x, that's an x-axis and that's a y-axis. We might be in some kind of like, maybe the area of science that we're doing wants us to examine how well this curve, well, I should say maybe we have a bunch of data points that seem vaguely exponentially curved shaped, but we want to see how true that actually is. It can be a bit easier to tell if you turn it into the logarithmic scale, where because logarithms and exponents are related, this will just show up as a straight line. And notice I wrote log base 10 of y there, which is why we're translating this into a line now. And so our data points are still going to like be here, but they'll follow along the line now because it already looked exponential, and when you take the log of it, you end up with a line because exponents and logs undo each other is kind of the math explanation. And these two things are completely the same. And we can say they're completely the same because we basically compressed sections of the graph down. It's where I was like trying to go with this, but I hadn't like built up to it enough, I think. So like this section of the graph here corresponds with this bottom part here. Oops, why did I write an arrow like that? Oh my God. And then this evenly spaced section now corresponds with a slightly bigger space up here. So each time we like do a compression, even though it's evenly spaced on the log scale, we're taking more and more of our linear scale. And so that probably doesn't make perfect sense because I'm not explaining it well. I guess I wouldn't blame you if it didn't. But I'm kind of trying to explain how it works. Really, the most important takeaway is that if it looks linear on a logarithmic scale, it's really exponential. And that's the most important kind of like application piece of it. And for the actual like how it works, it's because you're kind of like compressing more and more sections of your linear scale, which is what a logarithm does. So I hope I answered the question somewhere in there, or at least I gave you something a bit more to think about. I don't use them super often when I do math, which is part of why. Okay, I'm glad I'm glad I at least helped you a little bit, even if I didn't explain things perfectly. I'll drop the link in chat here that I'm looking at too. And so you can also do the log with the horizontal axis too, which is completely allowed. It's a bit easier to explain if we only look at the vertical axis and keep things and like, you know, keep that as a constant, but you can technically do a log scale with the horizontal axis too, or you can do it with both at the same time. I don't know what the applications of each of them are, because I know like the math part, but not necessarily the application part. Decibels are definitely log scale. Richter, I think it is. That sounds right. I don't remember. But like, yeah, with like sound, like decibels is how loud a sound is. The difference between 80 decibels and 90 decibels is way more than the difference between, say, 40 decibels and 50. And that's a product of, or that's, you know, consequence of it being a logarithmic scale. Even though they're only 10 apart, the numbers are higher up and the difference in loudness is still bigger. And Felix also said that I missed, log scale is really useful when it comes to verifying authenticity of research data. Rich, you watched a video by YouTuber Bobby Broccoli, and one guy got caught because his data was too nice, didn't have any noise, which can be seen using a log graph. Oh, interesting. Okay. See, I know log scale show up in many different applications. That's an instrument that I hadn't heard of. Hey, Cruz, I'll say, how's it going? Yeah, please do. Feel free to type it in chat right there, or if it's easier, you can put a screenshot or the question or whatever in my Discord. In the meantime, I am out of tea. Let me go put my mug away. Be back in a second. Actually, you guys will still be able to hear me. Okay. So in the meantime, I'll keep looking for questions out on the internet. So now's an answer. Fresnel integral? I just want to see what this is about. Roller coasters. Okay, I definitely don't know this math, but I'm just curious to see what's up with it. Hmm. Okay, just checking. Okay, yeah, I don't see anything from Cruise yet. No time pressure, just to make sure I wasn't missing it. Dang it. All right, nothing on this subreddit. Let's try this one. Oh, okay. I'm new to limit function, and I'm kind of confused. I need to give an answer of L or epsilon equals delta. Okay, so cruise. Are you trying to prove limits using epsilon delta, I guess? Or do you do you have to use epsilon here? Because you asked me about one of the calculus things that I am not comfortable with, but I can maybe figure it out, or someone in chat can give me a hand here. Actually, oh yeah. When you need to use it and when you don't. Okay, so I'll tell you the way that I've been taught. And I was not, when I took a calculus class, my professor said, oh, this epsilon delta thing exists, and here's the statement that you would need to prove, but we never actually worked with it. So let me tell you how I would solve this in the context of a calculus class as I've taken it. Because I have never done a limit involving epsilon deltas. And I majored in applied math, so usually you can do a limit with epsilon deltas, but as far as I know, there's always another way. So basically, yeah, what Felix is kind of like what I'm curious about, because finding the limit and proving it aren't necessarily the same task. So it kind of depends on how the question is being asked to you. So I'll show you how to find the limit, which I think you might already understand here, but just to make sure we're on the same page. The limit as x approaches 4 of x squared minus 5x plus 4? Yeah. And so if you try to plug in 4, you'd end up with 0 on top and 0 on the bottom. That's a no-no. We don't know what that means. But what we can do is find a cancellation if we factor the denominator, which I think you've already found, Cruz. But just to make sure everyone's on the same page, or I'll go through it anyway. So if you factor that, you get x minus 4. No, that's not right. X minus 1. So if you factor that, you get x minus 4 times x minus 1. The x minus 4's cancel. So you get limit as x approaches 4 of 1 over x minus 1. And now if you plug 4 into here, you get 1 over 4 minus 1 is 3, so you get 1/3. And that's just your answer right there. That's all the work that you would have to do in a calculus class as I took it. You never need to bring in epsilons or deltas. But there are some professors who want you to know how to actually prove that. Because I think this is like a solution technique, but not an actual proof, which is kind of, I think your question is about. So we found the right answer, which agrees with what you got. But actually, so I know this isn't an actual proof. This is just a trick. So if the question is just to find the limit, we found the limit. If the question is to prove the limit, we have a lot more work to do. And so I guess that's my question to you, Cruz, is are you being asked to find the limit or to prove it, I guess? And I know I just asked you a bunch of questions, so feel free to take your time. Or if I need to repeat anything, please ask me. Oh, it's YT. Maybe I should just make it YouTube though. So I spell out Discord, I guess. Oh, a dilution problem? Yeah, Enigma. It's my first time. Okay, so if you want to prove it, this is where I need to look up and or ask people in chat to help me out. I only vaguely know the idea here. I epsilon delta limit proof. If I can see an existing one, I can probably just replicate the steps. But this is something that my calculus class has always glazed over. Okay, and so I'm going to put it in kind of in terms of the real analysis class that I've been taking that's being taught by Zach on Twitch. So basically, like, we've been doing big N in sequences, but I think delta is just our big N when we're talking about continuous functions. And because things are continuous, we have to talk about the magnitude of x minus c being less than delta rather than a small n. Epsilon-Delta proofs, yeah. I guess it would count as self-studying Leopard. So I mentioned it early on, but e to the 2i pi on Twitch is just doing a live Twitch class, because Zach is a real analysis PhD student, if I'm not wrong. And so he decided to teach on Twitch just like an undergraduate level real analysis class. It's been a ton of fun. It's like the third or fourth week that we're into now, I think. Third. Okay, so here we're taking the definition of a limit, and we're trying to figure out what our choice of epsilon, or what our choice of delta is, given an epsilon. That's what our modes learn. Yeah, so it's not like through a university, or you don't get anything official at the end of it, but it's a fun thing to just like learn. So yeah, Chris, I'm probably going to replicate the logic used in this proof here. So this limit doesn't have anything. If the limit is infinite or doesn't exist, I think there's some more complicated stuff that we have to do. But in this case, I think we get to do things a bit simpler, thankfully. So I think we need to do some, I think this part appears basically our scratch work, where we want to figure out what delta we choose based on a given value of epsilon. And then the actual proof part is going to come once we've done that scratch work. So let's try this, and hopefully I don't explain it too horribly, or don't make too horrible of a mistake. So let me look back at the definition of limit quickly. Okay, so what we want to show is that given any epsilon greater than 0, there exists a delta, which is also greater than 0. such that for all x not equal to well, they say c, but we can just use... Do they define what c is? Oh, c is the actual like point. Such that for all x not equal to 4, if x minus 4 is less than delta, then f of x, I'm just going to say f of x and not write out the entire function, minus our suspected limit, 1/3 L, is less than epsilon. Oops, that's not epsilon. Wait. Writing my epsilons weirdly. I did the wrong. Okay, there. So this is, again, this isn't something I'm that comfortable with, but I'm trying to follow along the logic that's So I know a little bit about this, and then I think I can get to the finish line by following along the logic of the site that I'm looking at. So if we want to show this, we need to figure out epsilon is what we're given, delta is what we choose, and we need to figure out what delta we would choose for a given epsilon. Thanks for being a second pair of eyes on that, Felix. So this isn't part of the formal proof, but we need to work with kind of this and figure out what epsilon we want. So black is kind of dying on me. I need to get new ink for it. I might have been given ink when I ordered these. I'll need to check that. So f of x minus 1/3. So it's just like a scratch work here to inform what the actual proof will be. You solve for n? Okay, yeah. That's what I was imagining, Enigma. I'm trying to, actually, Zach's class is coming in handy here. Otherwise, I definitely wouldn't even have gotten this far, I think. So, following logic, I'm at this point, though, I am going to start to more blindly follow the logic that's on the website. So, by the definition of absolute value, we can also say this inequality is minus epsilon is less than f of x minus 1/3 is less than positive epsilon. F of x we know is that function. X squared minus 5x plus 4 minus 1/3 less than epsilon. And at this point, we'll do the same cancellation here that we did over here. And we're going to add 1/3 to both sides. So minus epsilon plus 1/3 is less than 1 over x minus 1 less than epsilon. And now, oops, plus 1/3. Almost forgot that. Now we need to flip everything because x is in the denominator and we don't want that. So when you flip an inequality, you do need to reverse the symbols here. So it'll be 1 over minus epsilon plus 1/3, now greater than, because we're flipping everything, greater than 1 over epsilon plus 1/3. And then you add 1 over minus epsilon plus 1/3 greater than x greater, oops, plus 1. I'm writing probably too small for you to see it easily, aren't I? Let me just rewrite that last step. 1 over minus epsilon plus 1/3 less than, greater than x plus 1 greater than x minus 1. Let me not make a mistake in copying things down. 1 over epsilon plus 1/3. Now you can add 1. The size is fine? Okay, good. 1 over epsilon plus 1/3. Now I'm adding 1 to both sides, I guess all three sides. Greater than x, greater than 1 over epsilon plus 1/3 plus 1. Okay, so this informs our choice of x here. some way. Now let me see how we interpret this. So I basically got into the step that they're at here. Desired from the last is 4 minus something. Less than x, less than 4 plus something. And 4 in this problem is the suspected limit. Or no, it's the point that we're approaching. 4 is the point that we're approaching, okay. Since we want this last interval to describe an x tolerance around 4. So in this case, we're also approaching 4. So I think this problem was engineered to give you the 4s. What do you do if you don't have the 4, or if you don't have the 4s? Leopard, you'll be having breakfast and going to work? Nice to meet you too. Thanks so much for hanging out. Hope that breakfast and work go well. Hopefully I'll be doing this more on YouTube too. Just use the delta min part. Yeah, they do seem to... Is that a guess, Felix, or do you know that that's okay? Because they do chop off the 4s, but I don't know if you have to engineer it so the 4s are there in the first place. Or maybe the 4s is just a coincidence there. Four minus something less than x, 4 plus something. I guess if we're taking the minimum, it should be okay if we take an even smaller value. So it just gets even closer to your, or that just is even better if you take a smaller delta, I think. Okay, so if I do get it into the desired form that that site says, we want to manipulate this part a little bit, so it's 1 minus something. We already have 1 plus something there. Can make some arrow spaghetti and come up here. So we can factor a negative sign out from the denominator and say it's the same thing as 1 minus 1 over epsilon minus a third. Less than x. Oh, no, do not flip it. I don't know why I flipped it again. Greater than x, greater than 1 plus 1 over epsilon plus a third. So if we are going to take that website's proof at its word, or we choose delta that's the minimum of 1 over epsilon minus a third, comma 1 over epsilon plus a third. Supplying squeeze theorem. Okay. Yeah, I mean it's still a. I don't imagine it would matter. This is how we choose our actual delta, and this is kind of, I think, the end of our scratch work. See, it's much easier to actually, it's much easier to find the limit than it is to prove the limit, as we're seeing. Of course, it'd be a lot easier for me if I had done this more, but. And then this right here is the actual proof part. All that work that I just did was so we could say basically this statement right here, particular to our problem. So given any epsilon greater than 0, we take delta Well, okay, I guess they say that for epsilon minus epsilon squared is always less than. Oh, so they just take the minus part because that's always less than the plus part. That's fair enough. It's a 1 over epsilon minus, oh, wait, no, plus a third. Because bigger denominator, smaller number. And epsilon is always positive. I don't know if that part matters, but. Sharing right now on PC for yourself? Okay. Thank you for that, Felix. Okay, so Cruz. This is not an easy thing to understand. I don't completely understand it. And I bet your classmates are feeling similar to what you just typed right now. It's not easy. I wouldn't feel bad for not getting this because it's something that I've like hearing about the existence of epsilon delta proofs made me avoid any type of proof class. But it's not impossible. I think it has a bad, or it has a harder reputation than it needs. It is something you can do somewhat formulaically, where you're basically always going to set up an inequality like this and try to figure out. Basically, you set this inequality, solve it for x, and that informs your choice of delta. And then the statements down here are more or less just plugging things in. I don't know what that is. Or I don't get the reference, but see, I'm sorry that I'm not better informed epsilon delta proofs to like really give you a good guide, because I'm just, you know, following on this website for myself. But I hope I've at least tried to show the difference between, you know, finding a limit versus proving a limit. Hopefully you're just asked to find limits and not actually prove them. If you're interested, I'll actually link this site too, because explanations are pretty. He's the inventor of the function. Oh, okay. But yeah, so in my calculus class, I never had to use this. I never had to actually use it like to this level, so. Oh, one second. Someone just DM'd me a quick question on how to factor something. I want to make sure that I tell them the right thing. You need to factor x squared minus x plus a quarter. Oops. That should be x minus a half squared. Right? Yeah. Let me just DM them back quick. Professor is crazy enough to add that to Thessalfina. I hope so too. for your sake and for the sake of your classmates, because it's not easy. Okay, sorry about that. I was just typing back to this person. Oh, that's right. I was looking at this. Someone else already answer it? No? Is there a trick here where x is going to be your total solution now, so you should do x minus 10 for how much you add? They said 0.4n. Oh, no, yeah, that's just a little smudge, I think. I think they flipped something, though. It should be 40 over 6. Right? Wait, that's not right. What do you do? Dude, see, as soon as a science gets involved, I just completely lose my mind. I'm going to Google the exact question and see what comes up. Should be added to 10 mil. And hopefully we at least find a similar one. Six N acid solution. Oh, it's supposed to be M? That makes sense. Molarity. Okay, so it is what I was thinking. At least according to Quora, which maybe we shouldn't trust Quora, but this is what I was thinking anyway, so I'm inclined to trust it. They set it up a slightly different way. I think it's the same. You should end up with the same result. So the proportions are the same. I think these ratios are going to be the same. They have to get it to 0.5. We have to get it to 4. So wait, they do get... No, it should be 6D. Why do you get less? Like... If it's... Is there something wrong with this? Because you shouldn't get something that's less than 10. You need to add water. Do you do x plus 10? And you would add? No. Maybe if you set it up like this. Oh man, I wish Shep was here. Maybe I should just move on if I'm not like confident in this. Double limit proof. I try maybe using that 4 minus x over 3 times x minus 1. Where would you use that, Felix, I guess? Or I guess like, how's that helpful? Or is it different from what I did? That's what I don't understand right now. to make this expression work after. Okay, so there. Oh, okay. Give me a second to realize this person is asking, but. Oh, Mina, okay, yeah, I assume it's the same Mina that I just talked to this morning or an hour or two ago. Yeah, I'm dual streaming. It's my first time, so I'm just like trying it out. It is you? Okay. Yeah, it's been interesting so far. Okay, so they have the right idea where instead of x equals 72.5 and 287.5, and instead you, well, ooh. See, your period is changing, so it's not necessarily 360k plus x, is it? And 360k minus x. This is how I would usually solve a function like this, but now I'm getting a little bit held up on the actual period part. Yeah, I think you need to divide the period by 2, so you do 180k? I need to figure out, like, what do I Google to figure this out? Actually, I can probably reverse engineer it from, 0.13. Two pi n minus 15, 1/2 of that. So yeah, you do need the 1/2 in front, versus if you had just x plus 15, you don't have the 1/2 in front. Okay, so cosine 2x plus 15 equals 0.3. Because this is stuff I do intuitively, but I don't actually like think about it, so that's why I need to think about how I put it into words. X equals 72.5 degrees. It's 2x plus 15 equals 72.5 degrees. I think it's 15 degrees, I guess. Well, the entire thing is degrees. So, oh man, you subtract 15 divided by 2, and then you do your transformations, I guess? Oh, Felix, let me see what you're saying. 4 minus x over 3x minus 1 is less than epsilon. 3 is less than x is less than 6. X minus 4 is less than delta. Why is 3 less than x less than 6? Is that... Why not 3 less than x less than 5? Is 6 a more convenient number to choose? Because you get a cancellation, maybe? Oh, okay, 5. Find a delta such that f sub I x minus 4 is less than delta. Delta equals 6 times epsilon. Does that... But if I... Oh, well... I guess it's... Oh wait, if you're using the 3 is less than x is less than 6 trick, doesn't the numerator become 0 over that interval when x equals 4? Is it as simple as that? It's just using the endpoints? Or, 3 is less than x is less than 5. Either way, you'd have a 0 in the numerator at some point. Does that make it potentially invalid depending on the function? Because it's not like monotonically increasing or decreasing, maybe? I guess the more important is if it's monotonically increasing or decreasing, or if you actually... I guess x it doesn't equal 4, you're right. I'm not sure. I wish I... Like, do you know that 3 and 5 are the minimum and maximum? I guess it was my concern. Unless that isn't needed for what you're saying and I'm not understanding. We know that x equals 4 is between those two numbers, right? Yeah. Do you solve for the 4x though? I don't know. Ugh, man. I have a very hard time saying if that's right or wrong because I don't know enough about it. Actually, let me make sure that no one else beat me to the punch here. Ah, Alkaliner. Let's see if I have anything to add on to Alkaliner's response. To do your Epsilon Delta proof of yeah, my concern is that I'm not good enough at this to know if that's right or wrong. It might be right. I just don't know. Maybe it's easy proof by contradiction. I mean, that could be pretty hard too. I think Alkaliner kind of covered it. I might just... Oh, they delete... Okay, yeah. They got their answers, so they deleted their post. Unfortunately, I wish that they'd leave it up. They'd leave it up because other people are going to have the same question, but oh well. Can't control that. Yeah, sure, Cruz. I mean, I can't promise that you'll get a clean answer from us, but you can sure ask it. And I'll do my best to give you an actual clear explanation. Yeah, me too. I should just make epsilon and delta like banned words in chat. You know? As soon as you say epsilon or delta, just permaban. It's not allowed here. No. If it is epsilon delta, I'll try my best on it too, but no need proof. Oh, thank God. X approaches 0 of 1 plus x to the 4th minus 1 over x. Okay, so I assume... Okay, so I'm going to rewrite what you've typed, and let's make sure that I'm interpreting what you're saying right with the parentheses and all. Because I think there's a little bit of ambiguity here. Is the entire thing one big fraction? Or are there like two separate terms here? Oh my God, this thing refuses to erase. Smirker is too strong for me. Jeez, okay. Oh my God, okay. Even though it's kind of an angry color, let's use red because it at least erases. Okay, so we have x approaches 0. One plus x to the 4th, was it? Minus 1 all over x is my interpretation. Because you said that we end up with 0 over 0. Okay. So... Wait, you came up with x to the fourth plus x squared over x. Oh wait, so that's kind of the hard part, or that to me is the hardest part done. So I don't see an easier trick, unfortunately, than multiplying this entire thing out. There is going to be a nice simplification once you do multiply everything out. But I think you do need to do out that 1 plus x to the fourth. Let me do that in Wolfram Alpha and verify what you got. There might be some crazy factoring trick that saves you some work. I just don't know factoring tricks. Oh wait, so you don't get just x squared plus, or x to the fourth plus x squared. If you were to go through the trouble of multiplying out that 1 plus x to the fourth, you should end up with, and I mean, I'm too lazy to do it, which is why I'm just using Wolfram, but you should get x to the fourth plus 4x cubed plus 6x squared plus 4x plus 1. And then we still have the minus 1 that's right there. And that minus 1 is very important. Because now we have plus 1, minus 1, they're going to become 0. And you just end up with, limit as x goes to 0, x to the fourth plus 4x cubed plus 6x squared plus 4x over x. And now we get a very nice cancellation. Welcome back, Amina. Now we get a very nice cancellation because everything on top has an x term, the bottom has an x term. So we can cancel out one of these x's from everything. So the x to the fourth gets one of the x's canceled to become x cubed. That's supposed to be cubed. I just can't write threes. 4x squared plus 6x plus 4, technically over 1, because that x canceled became 1, but over 1 is irrelevant. And now this is something we are allowed to plug 0 into, because we don't end up with dividing by 0. So if you plug in 0 to all these, you get 0 plus 0 plus 0 plus 4 is 4. So the thing that I noticed when you first said the problem is that whatever this multiplication comes out to be, you're always going to end up with a plus 1 on the end there. Because there's going to be, 1 times 1 times 1 times 1. And then there's the minus 1 right after it. So I thought that we're going to get the plus 1 minus 1, and everything else has x's. And that was kind of like my approach when I saw the problem. And I only knew that because I've done problems like this a million times. But I'm telling you that same trick, so hopefully you can start to see the patterns for yourself too. You forgot the 2AB? Oh, okay, that'll do it. Oh, L'Hospitals, Mina. Do you know L'Hospitals, Cruz? That would have been a lot easier. Or it would save you a lot of work if you're not allowed to use Wolfram Alpha. The hospital, yep. L'Hôpital. Is it L'Hospital's rule or L'Hospital's law? L'Hospital's rule, okay. Does this look at all familiar to your Cruz? And if not, it's no worries at all. But yeah, Mina did just point out a way easier way to do this problem. That's more realistic to do on an actual test than what I did. So I cheated and used Wolfram for a part of it. Okay, Cruz, I'm not seeing a response from you, but I'm just going to explain it anyway. And if you haven't learned this, just don't worry about it and don't pay attention to me. But I'm going to go and explain the L'Hospital's way to do it too. So yeah, as Mina rightfully pointed out, if you try to plug the limit into the initial function here, you end up with 0 over 0. That's an indeterminate form. Oh, okay, Cruz. So can't really use. Wait, really? Oh my god, Stooky. I didn't know it existed for that. I thought it was only sine x over x. I didn't know that that issue came up for other things. Oh, you're right. That's the definition of a derivative, isn't it? That does... I get it. Okay. It's a little sus. I'm going to do it anyway. I assume in the context of a calculus class, that technicality wouldn't come up. But it depends on how rigorous the teacher's being, I guess. Okay, so let me explain what L'Hopital's rule is first, or when you can use it. And then I'll get into what Stooky is saying. But I think in the context of what Cruz is doing, it shouldn't matter. At least I hope it wouldn't. So I think the intent of this, I would think, is that you're supposed to use L'Hopital's. So if you try to plug 0 into this thing as is, you get 0 over 0. That's called an indeterminate form, and it's called indeterminate because we literally don't know how to determine it. It doesn't make any sense. Like, what is 0 divided by 0? I think it's a different thing, Cruz. That might come up sometimes, but I think it's a different thing. Or it might be a... You might be talking about like maybe a specific instance where you can use it, but what L'Hopital is really about is that if you have a limit that results in an indeterminate form, like this 0 over 0, there's other ones too, like 1 to the infinity is indeterminate. I think 0 to the power of 0 might be indeterminate. There's a bunch of them. The most common one is 0 over 0. Oh, and thanks for following. So if you end up with an indeterminate form of any kind, usually 0 over 0, you're allowed to apply L'Hopital's, which basically you derive the top and you derive the bottom, and the limit still applies. And often people apply L'Hopital's, they write an L apostrophe H over the equal sign just to kind of explain what happened. It's not technically required, but it can make your work a little bit more readable. So since I'm applying L'Hopital's in this step, I'm putting the LH there. And I derive the top. It's not a quotient rule. You derive the top on its own, you derive the bottom on its own. So the top, 1 plus x to the 4, chain rule. The 4 comes down, you get a power of 3. That's not a power of 3, is it? Cubed. And then the inside derives to 1, so just times 1 there. Minus 1 derives to 0, we don't have to worry about it. X derives to 1. So now we know x approaches 0 of this function, and it's way easier to figure out. You can just plug 0 in directly here, and we don't get any indeterminate forms, so you just get 4. Same exact answer, and much easier. And what Stooky was saying is that there's some edge cases because L'Hopital's requires, or it relies on derivatives existing and like the theory behind derivatives. There's some situations where it's logically invalid to apply it, even though it looks like you can. This is, I guess, kind of suspicious, but maybe okay, is what Stooky is saying. And that it's a potential issue because this is the exact definition of a derivative. Like the limit definition of a derivative. And it kind of like raises question marks, but I wouldn't worry about it too much in the context of your normal calculus class, because normally they just don't even cover it in the first place. You're allowed to do that? Yes, you are. Like, I'd say 99% of the time, you can just derive the top and derive the bottom, and the limit is still completely valid. It does have to have the indeterminate form, but if that condition is met, you're allowed to do it. We say it's equal to f prime 1. I think that's the situation where that definition would derive Mina. And so Mina's saying this is what you would, I think it's what you would end up with if you were using the limit to find f prime of 1 when f of x is equal to x to the fourth. If you use the limit definition of a derivative here, you'd end up with that setup, which is why it's potentially weird. The most famous case where you're not allowed to use L'Hopital's is the limit as x approaches 0 of sine of x over x. I don't want to get too far into like why, because it looks like it looks like you can apply L'Hopital's, and if you do apply L'Hopital's, you get the right answer, but it's for the wrong reason. So if you ever see this limit in particular, it's a pretty famous case of just L'Hopital's being logically wrong. Even though it gets you the right answer, it's for the wrong reason. And it's a pretty complicated limit, or it's not that complicated, but it's a little complicated to show the limit without L'Hopital's, but there's like a geometric thing that you can do there. So yeah, I hope that helped you out, Cruz. I see, thanks a lot. Okay, glad to hear. So L'Hopital's is a really nice time saver. Actually that was a nice demonstration of why L'Hopital's is a nice time saver, because I did it the long way for my first instinct because I wasn't sure if you had it. But it's much easier with L'Hopital's. So I'm probably going to get things wrapped up for the math soon. So I am past the 2-hour mark. But if anyone has any questions, like Cruz or anyone else has a math question, I will take some extra time to do those. I could look at the real analysis stuff too, I guess. It's because it's blocked the sine cosine. I'm not sure about that, Cruz. So the reason that you can't do it is that proving that sine of x derives to cosine of x, if you try to do that problem, it actually requires you to use the limit as x approaches 0 of sine of x over x. So since you already have to prove it, since you already have to figure out what that limit is before you've even proved what the derivative of sine is, it's not valid to use L'Hopital's in that specific case. It usually don't have that issue 99% of the time in your normal calculus class though. But it's just because that limit happens to come up if you prove the derivative of sine using the limit definition. So, Chris, do you think you're gonna have any other questions? Actually, well, let me look at the real analysis stuff, because I might keep doing math for a while longer. I don't know how much more thinking I'm going to do, but I'll keep the math going for a bit longer. Normally how my streams go for anyone who's new is I do 2 hours of math, and then I switch to some kind of game, which isn't going to be on YouTube. I think I'm just going to cut the stream off once I'm done with math. And I am a bit past the 2-hour mark, but I do kind of want to keep it going for a bit longer. So Cruz, if you do have more questions, feel free to put them in chat. Otherwise, I'm just going to be doing some real analysis studying, basically. So this is a part of e to the 2i pi's class a few hours ago. And they got through a good amount of the problems, but there's still some left on the table, and I just want to see what they look like. Ooh, a Cauchy sequence. I shouldn't skip questions, though. I think we should build up, maybe. So we're potentially going to do question 5 here. You're testing the f of x. Okay, sounds good. Let me know if you run into any issues. Okay, my eyes did skip ahead to 6. That the square of a convergent sequence is equal to the square of a limit. And I would think based off the proof we did for 4, which I don't think we actually got to I don't think we actually proved it during the class today, but Zach kind of went back and clarified it. But I think based off what we did for 4, you just take b sub n equal a sub n, and you've proven it. I think calculator, this is not a drill. I am curious to see what's up with this. But I might rely on the questions before, which is why I feel like I shouldn't. Oh my god, hearts? Diamonds? Spades? What does this mean? Okay, this has me interested. What is that Greek letter? It's a capital theta? It's like it's all theory needed to do 3 to 3 9. Oh, okay. So yeah, I definitely shouldn't attempt it then, but 99% sure that's capital theta. It's an n such that if two indices a, b greater than n, then the difference in the terms is less than epsilon. So it's slowing down? The difference between the terms is decreasing more or less. Hey, Bookbinder. Wait. See, Bookbinder, I've answered a fair few questions off the internet, and I'm kind of running out, so I just like get you up to speed. I'm going through some real analysis, kind of like study questions now, unless someone happens to ask a question in chat. So these are questions I'm just kind of working on for fun and like discussing it. This couchy one I was looking at for fun, but I definitely don't have the background to do it. I just wanted to see if I could figure out what it even means in the first place. But my interpretation of at least this statement is that your sequence is basically slowing down. Like it seems like another way of saying convergent, but that might not be the case. I don't exactly know. I should probably look at the earlier questions that kind of are the theory that lead up to that question, probably. I'm kind of looking at 3, because we did skip over it. Zach said it was kind of an extension of 2. But I want to see what's up with it, I guess. The family of sets, where k greater than 0 and k belongs to natural numbers. Check absolute values of k when you work this prompt. Oh, God. So it's... the current time over there in Cali, it's 3:30 in the afternoon. Oh, C is a rational number. And I think that's psi. It's all perfect squares up to a given value k. Any problem solved up till? So over on Eats Its Way Pi stream, it's like the class is structured like as a kind of group discussion, or it's very discussion based class. So as a group, we worked through the first question, which were kind of some review things of previous classes. Question 2, which was finding the minimum and maximum and kind of defining supremum and infimum, saying those right, of a couple of given sequences here. We skipped 3, which I kind of want to revisit because it might help me. Examining a set of a set might help me later on in the class. And then we ended on question 4, involving proving things about the product of two convergent sequences and what that product converges to. We didn't actually end up proving it, but we got kind of close-ish. Are we going to do the stream? Normally I only do math for like 2 hours, and then I do video games, which would happen just only over on Twitch. If I'm feeling the math, though, I go for like 3 or 4 hours, and it's probably going to be that kind of day for me. I'm at 2.5 hours, so at least another half hour, I'd say. And at least for this part, it's going to be more of like a study session, unless someone comes in asking me a question specifically. Anders, this is I was looking at question 3 here from the questions that we were doing this morning, or a few hours ago. I started this channel actually a year ago to today. At least I started my Twitch channel. My very first stream was a year ago today over on Twitch. The YouTube channel was a few months after that. But it's my first ever YouTube stream, and it's the 1 year mark for my Twitch stream, I guess. So I need to understand what's happening with this whole psi thing. So the family of sets, I don't know if that's a typo or if I'm supposed to, that means something. Many luck to you. Oh, hey, thank you, Bookbinder. Yeah, so this is something I'd love to be able for it to grow to a point where I can do it for a living. And so may as well try streaming on YouTube to see if people are interested. It seems like they are. I got more interest on the YouTube side than I thought I would. Let's try green. So k greater than 0. K belongs to natural numbers. I should get a better. How do you write the frickin'? I guess like that. That's a better way to write the natural number n. It's kind of annoying. Oh no! Oh my god. Okay. My phone died. Wait. Oh yeah. It's annoying. I use my phone for my big camera, and my phone just died. I completely forgot to check its battery. Where do I put it? I guess I'll put it there. I should make a separate scene for when this happens, because it happens so often. Can you solve the application of definite integration? What application? Or like, can you be more specific? Maybe like, how do you do? I could say how you do an indefinite or a definite integral, but I'm not sure if you mean something else with the application of that or what. Parabola, ellipse, and circle? I'm sorry if it's me being slow, but I'm more confused now. So those are conic sections, I guess. Like integrating a parabola and ellipse in a circle, or not conic sections. Actually, are they? Yeah, they are conic sections. See, I'm like finding the area of those things using integration. I guess the area of a parabola. I guess that depends on how you want to define the area of a parabola, but exactly that. Okay, so let me show the idea for at least a circle, I guess, and see if we're on the same page, because a circle will be a relatively simple case. So let's pretend you have a circle, and the center of it is arbitrary, so let's make our lives easier and center the circle at 0, 0, because the area, you know, making the center somewhere else doesn't change your area. We'll say the circle's radius a. So the equation of the circle is x squared plus y squared equals a squared. And if you want to find the area of the circle using integration, I hope this is readable on the stream, by the way. I think it is. It's hard to tell in the OBS previews sometimes. Basically, our equation is x squared plus y squared equals a squared. Actually, I should say r. It'll work out a bit nicer. Or it'll look nicer. It won't change anything. What we can do is we can solve this in terms of y. So we get y equals plus or minus square root r squared minus x squared. And we need to do this because we want y to be in terms of x or x to be in terms of y, so we're only integrating one variable, otherwise things get weird. If they even make sense in the first place, I'm not sure. There's a little issue where we have the plus or minus square root, because you have to square root each side on the way to getting this, and so you have to add the plus or minus. The plus part corresponds with the upper half of the circle. The minus part corresponds with the lower half of the circle. But we're integrating, we're finding the area, so let's just find the upper half of the circle and multiply by 2. So I'm going to set up our integral as, actually we can even multiply by, I'm not going to do that. 2 times the integral from minus r to plus r, because we're going from that end of the circle to that end, of, taking the positive part, r squared minus x squared dx. Now you can even multiply by 4 and do 0 to r, because the circle is also, the circle is symmetric both horizontally and vertically, but I'll just do minus r to plus r. And you solve this with a trig sub. You would say u is equal to 1 over r squared sine squared? X over r, maybe? I forget. I need to verify that sub. Where's Paul when you need him? Paul? No, that's not Paul. You're not my real Paul. Greetings from Ecuador. Ooh, that's awesome. Nice channel. Welcome in, Mario. And thank you for the kind words as well. I don't think they do trig subs in this part, do they? No. No, trig substitutions. And there's a convenient format. We have this situation here. A is r, b is 1. So it's r squared times... Oh, oops. I did it backwards in the first place, too. Okay, I'm glad I checked this page. So we need to do x equals r sine u, or we can do a theta sub too, it doesn't matter. It's just a letter. So let me fix my... And actually, I do want to do theta. It's a fun letter. So our sub actually is going to be x, because I had it backwards, r sine theta. Yeah, that's good. Okay. So let's plug out, and that means also that dx is equal to r cosine theta d theta. We'll need that when we plug in here. So 2, the bounds are going to change. If x is equal to negative r equals r sine theta, that means sine theta is equal to negative 1. So theta equals 3 pi over 2. And if r equals r sine theta, then sine theta equals 1, so theta equals pi over 2. That's interesting. I'm gonna have to flip things around a bit. So our integral is going from 3 pi over 2 to pi over 2, but that's improper because pi over 2 is less than 3 pi over 2. So we're gonna have to do a negative and flip it around, I think. And it should work out. And then plugging in inside here, r squared minus r squared sine squared theta. And then dx becomes r cosine theta d theta. Now I'm going to put a negative in front of the integral and flip the bounds. I feel a little bit less confident now, but I think everything I've done is valid, so it should work out. The minus sign should go away at some point, I'm hoping. Let's factor the r squared outside and bring it outside the square root because it's a perfect square. You know, but 1 minus sine squared, which is the same thing as cosine squared, using the Pythagorean identity, times r cosine theta, d theta, minus 2 pi over 2, 3 pi over 2. R times r is r squared. Root cosine squared is cosine. Cosine times cosine is cosine squared. Theta d theta. Now, r squared is just a constant. Cosine squared, you need to use a half angle identity. Choose your favorite one. Should all be the same. I'm going to say... Actually, well, there's only really one that you can choose that actually saves you time. I'm going to come up here. And say that cosine squared... Actually, let me write the rest of the integral first so I don't have to do things in my head. Minus 2, I'm going to bring the r squared in front because it's just a constant. Oops, not 0. Cosine squared theta now is equal to cosine 2 theta plus 1 over 2. Or I'm going to say 1/2 cosine 2 theta plus a half. So going from cosine squared to that is just a trig identity that you just kind of got to know, unfortunately. 3 pi over 2. Actually, wait, we're ready to integrate. Because we've gotten rid of the cosine squared, so we know how to integrate the rest. Minus 2r squared, and then the brackets will be whatever I integrate. So you have to do a little u sub for that 2 theta. I'm just going to do it in my head. Cosine integrates to positive sine. You have to divide by 2 because of your u sub. So you get 1/4 sine 2 theta plus 1/2 integrates to 1/2 theta. And we're dividing from pi over 2 to 3 pi over 2. Good? Minus 2r squared. Okay, so sine of 3 pi over 2, or sine of 2 times 3 pi over 2 is sine of 3 pi. Sine of 3 pi is 0. So you get just plus 1/2 times 3 pi over 2, 3 pi over 4. I really hope this works. Minus, now we do pi over 2. Sine of 2 times pi over 2 is sine of pi. Sine of pi is 0. So you get 0 there, plus 1/2 times pi over 2. Oh no, the minus sign doesn't go away? Oh no, I did something slightly wrong. The minus sign shouldn't be there, but otherwise I got the formula right, which is pi r squared. I think it's something I did with my bounds. Or, no, I shouldn't get a negative area. I should get a positive area. Excellent. I mean, it's slightly wrong, but the idea is right. If I did do the 0 to r multiplying by 2, would that save me from my incorrect bounds? Just try correcting my work a bit and seeing if this r sine theta theta equals 0. So now we get, oh, now we get 0 to pi over 2. And you don't flip. That was my issue, I guess. Because now it's proper. Okay. So yeah, just that one little mistake cost me a negative sign. What did it cost? Everything. It's what I'm sure there's a way that I could have made my way work. I know the board's farther away because my phone died, and this is just my webcam right now. In typical me fashion, I forgot to check my phone battery as I was streaming. So I just made my webcam full screen. Zero to pi over 2. 4. Four, 0 to pi over 2. Get rid of that. Okay, now let's just do the very last step here. Sine of 2 times pi over 2 is sine of pi. Sine of pi is 0. So you get 1/2 times pi over 2 is pi over 4. Minus sine of 0, 0. Oh, hey. There we go. Pi over 4. Positive pi r squared. That's what you're supposed to get. I'm I just messed something with interpreting my bounds. You already knew my mistake? Yeah. I just messed up with my translating my bounds for the X sub, or theta sub. Right cupboard reveal? Yeah. It's empty too. I had things in it, but there were a lot of like boxes of things that I had like gotten shipped to me, and I didn't want someone like zooming in and like seeing my address on a label or something. Veb, no idea how to pronounce that otherwise. Welcome in. How do you find or disprove the existence of a cuboid where all the values are integers? I have no clue. That's not my specialty, or that's not an area of math that I'm very familiar with. You almost wrote farter? I would have loved it if you did write farter. Knowledge having great camera quality? Yeah, exactly. I don't think my camera's like that high quality, but you know, why risk it? So, but I know that you asked about ellipses and parabolas too, but I think it's going to be a little bit, unless you really need to see it, like it's going to be the same idea as what I just did up there. So I think I'm just going to leave it at that, because I would like to study some of this real analysis stuff. Also, hi Spectry. Hey, Inshuman. You're done now? Okay. I don't mind doing math for fun too, but if I'm going to be doing math for fun, then I want to like spend a bit of time doing this stuff too. Okay, so where I left off was figuring out this family of sets, which, I mean, Zach, if you are here, and it's okay if you're not, you wouldn't hear me saying that if you weren't though. Is the family of sets a typo, or is that something I just don't know? Like, I know that a set of a set is a thing, but is that how you say that? Just sets? Okay, the family of sets. The time here is 3:53 in the afternoon. Okay. So that makes me feel a bit better. It's like, man, there's literally a lot about set theory that I don't know. I do not approve of that terminology. Oh yeah, Zach, I don't think you were here, but I was joking that I'm gonna make epsilon and delta banned words in this chat. Because someone was actually asking about an epsilon delta proof earlier. But in the automobile, yeah, exactly. India, it's 5 in the morning. Oh, wow. You read a match stream already? I was able to half answer their question, actually. So, no, you unironically have helped me, because I was able to like think about it in terms of the epsilon n proofs that we've been doing. So I wish I could have given them a better, like more rigorous explanation, but I was able to look up a similar epsilon delta proof and follow along the steps. I still want to make them banned words though. You know, I didn't enjoy it. So it absolutely does make me a better streamer though. So thank you for that. Ugh. Maybe is it the eraser that's not working right? Probably. Or I just need a rag like Zach has. This thing is getting really smudgy. I need to go at it with my spray after the stream. Okay. Haven't even talked about that yet? So I know what's coming. Oh, you're out here, Bookbinder? All right. Much love to you too. I'll see you around. And I hope you have a good night too. Okay, so we're thinking about this whole psi business here. I'll do it in red because we've been talking about epsilon delta, and so I'm super mad now. K greater than 0. K belongs to natural numbers. We have this psi sub k equal, oh no, equal. C squared less than k, where C belongs to rational. How do you make that Q? There, that's your fancy Q. It's literally impossible to make. Ben, no, you're good, dude. It's never an obligation to watch. Then draw a diagonal line inside the Q. Oh. I guess when you write it by hand, you make that maybe like that? Other way? Like that. Okay, that's much easier. You sign the waiver, you have to be here? That's how you do it? Okay, that's a lot easier. Okay. So, all C squared less than K, where C is a rational number. So if, let's say we have K equals 10, maybe I'm getting a little ambitious here, then psi sub 10 is, let's start with only whole number, natural number C's. So 1 sure works, and it's the output of C squared that's a member of the set. So 4 and 9. That's the natural numbers. And then C is rational though, so we have infinitely many things where 1/4 is possible, right? Because 1/2. We can have a third, we can have a quarter. Dot, dot, dot. We can have the same thing, but now 2 as a numerator, which means 4 is the numerator, which is 1. You can have 4/9. 4/16 is 1/4. It's already included. 4/25 is new. And then we have the same thing with 3 as a numerator. So 9/4 is still less than 10. 9/9 is 1. 9/16 is new. 9/25. Dot, dot, dot. Actually, and I figure you could, your numerators can go beyond 3. Smetry found me? You tracked me down? Do you want mod in the YouTube chat too? I gave mod to Jed. Obviously, it's an obligation to watch through YouTube, but or to watch at all, but much less through YouTube. But actually, I'll just give you mod and you do whatever you want. Yeah, power. Okay, hell yeah. The stupid YouTube. There's a heart thing in the way of me being able to mod you. Get this stupid heart off my screen. There we go. Okay. Add as moderator. Managing mod. Okay. You should have a mod power now. But you watch through whatever medium you want to watch. Oh yeah, you got the wrench. Nice. But yeah, if you just want to keep watching through Twitch and ignore YouTube, it's completely fine. Because YouTube is just something I'm trying out too, so I don't even know if it's gonna stick. I think it will, because today's gone pretty well, but for now I'm just trying it still. Okay, so I think this is a mostly accurate representation for psi sub 10. There's infinitely many members, I guess. And if we were to follow this line along, like this line in particular would approach 0. The drip is the most important part about mod. Yeah. See, you get it. So we could consider, it might be instructive to consider k equals 1. Actually, I guess, is that just that? Yeah, it's just that. 1/4, 1/9, 1/16, 1/25, 1/24. And we're strictly less than, so we can't do 1 exactly. And so if you did k equals 1/2, you're basically just taking a further starting point of that series for any k less than 1. I think. Are there any other weird k's that we should consider? Like k equals pi doesn't really, it's not really significantly different from what we did for 10. Okay, so I think I have a grasp on what just the prompt means. We are interpreting the question a different way? Okay, please tell me if you have a different interpretation, Anders. The element C that check the condition. So not C squared, but just C. Oh, you can have the negative versions too. Okay, so at the very least, they have all pluses and minuses. I completely do not consider negative numbers. Okay, and so you're saying, hey, Skirtle, green? Okay, I'll switch to green. I'm not going to rewrite everything that I just did, but I'll switch to green. So now we get psi sub k goes from minus root k to plus root k. Oh, so it should be 1, 2, 3 rather than 1, 4, 9, plus or minus? Zach might not be here. I feel like it should be c squared. Oh no, maybe you're, no, I don't know. Oh wait, so what Anders said, where it's all C and Q such that C squared is less than K. Okay, so I should do the square root of everything that I just did. Okay. Okay. That's fair enough. You know, I guess I will have to, I mean, I don't have to rewrite all of this, but I think it's worth actually writing out some of the stuff again. And for Skirtle, I'll switch over to green. Plus or minus 1, plus or minus 2, plus or minus 3, and then 4 squared is greater than 10, so then we don't cross over, or we don't do any more. Not dot dot dot, not dot dot at all. And then we consider rational numbers, so we get plus or minus a half. Yeah, everything with 1 over is going to be valid. Oh, not 4. 3. So you can do any integer in the denominator when 1 is on top. And now if we have 2 in the numerator, we can do plus or minus 2/3. 2/4 is redundant. 2/5 dot dot dot. We have 3 in the numerator. I don't know if it's that important to go, like how far we need to take this. Our fractions always have to be less than 3. So, I mean, technically you can have, hoo-hoo, hey! It's a little hard to read your whiteboard. It looks fuzzy. Ah, dang it. I could pull a Dan and open up Paint. Woohoo. How are you? You're on 1080p? Ugh, okay. You know, let me just open up my own stream and look at it too, just so I can see what you're saying. Oh no, I really believe that it's blurry. I'm just it is just my webcam. Oh man, you're right. That's not easy to read at all. Yeah, that's not gonna work. Thank you for telling me, Zach. Shoot. And I messed with the cropping of my cam. Let me one second. Copy, paste. I'll go over here. It's good enough for me for now. Actually, no, I need to scale it up a bit. And then we can bring this back up. I'll just put it up there. Your first class today since school restarted. Oh, cool. Glad it went well. Okay, so how the hell does Dan do this? K greater than 0, K belongs to N. I mean, I can even open up the Discord activity just with myself too, I guess, but I'm already doing this. Oh, actually, I should do green. Devolve? Yeah. It's too hard to read my whiteboard just through my webcam, so I'm just gonna do the good old-fashioned paint. The newt from The Little Mermaid? Oh, the symbol here, hoo-hoo? Or what newt was in The Little Mermaid? I'm trying to think of it. Or was it the song? I don't know. Exams are coming up. Ooh, oh, okay, Spetri. Good luck to you. Just trying to repeat some of the work that I had. Reads. Oh, yeah, the trident, her dad's stick. It does look like it. It's the Greek letter psi, but it is basically a trident. Yeah. What did I say? 2/3. Did I split 2/3 twice? Oh, that's 2/5. I see. I mean, there's a bunch of fractions. The point is that they're all less than 3. Even then I was, oh my god. I need to crop my paint maybe so I don't accidentally go off the edge of the screen. Like I already have done once. It's actually, okay, let's bring the paint over there. And then let's maybe get the Firefox over to the side. Ah. Zoom out once, maybe? Hopefully it's still readable. Okay, let's call that good for now. Oh yeah, dude, that compression is real nice. Look at that. Oh my god, okay. I'm already... I don't know how Dan that does it so quick. Okay, so question A, what is the minimum element of each set? Well, you make the board bigger in paint. Oh, you can make the board. What do you mean, like the canvas size, I guess? Like this? I can bump it up to like 3. Don't maintain aspect ratio. Bottom right. Oh, to zoom? Yeah, oh yeah, but the size of it is still the same at least. Oh my god. 50% increments? That's how you think I want to zoom paint? Okay, sorry. I like to yell at programs when they know exactly what I want, but like, who zooms in 50% increments? Like, I can't get like a little bit finer adjustment. It's fine. Oh yeah, I just started streaming on YouTube too. So right now it's both on Twitch and YouTube. So if you want mod powers over on YouTube too, I'll give them to you. Zoom out and drag the board. You know, I feel like I'm already yelling at paint enough in case you would want that. Okay. For now, I'm just gonna I'll cross that bridge if I run out of room. Minimum element of each set. You get a cool sign. Yeah, you get a little wrench next to your name if you're a mod on YouTube. So the minimum element is, well, it's like taking our size sub 10 example. The minimum element was -3. How do we express that generically? It's like it's weird because you have to like you don't have to do this, or I can like message you off stream and we can like set up if you want, but the stream's also on YouTube, and so if you were interested in watching it through YouTube instead for whatever reason, I can give you mod powers over there too. And I can't actually link my stream directly because I think it's against Twitch terms of service, but I can link my channel as far as I know. But if you just want to hang out on Twitch because it's easier, I understand. But I'm trying out doing the dual stream to both Twitch and YouTube at the same time. I assume it's a loophole. Twitch's rules are kind of vague in that respect, so... Like, I can't actually tell people to go, like, you know, oh, leave Twitch, come to YouTube, but I can't imagine I'm not allowed to advertise my YouTube channel in a vacuum. So for k equals 10, the minimum is -3. How do we express this generically for any k is my question. Because root 10, oh, it's just floor. Min for k greater than 0. I know who I was trying to say it too. Let me. Okay, I'll DM you on Discord. Because the stream is also going on over on YouTube. How the heck do I get to my own YouTube channel? View your channel, probably with that button, right? That seems... Okay. Get that. You can put that back. Okay. All right, Spetri, I'll see ya. Thanks for coming by. I hope you enjoy your New powers. Okay, so for k greater than 0, I think our to infinity stones, yeah. I see to start streaming to 3 more sites. Well, I guess 3 if you count Discord, yeah. So you just need two more areas, and then you're the infinity mod. So we gotta define it a little bit carefully. We have to do negative floor square root absolute. No, we don't need absolute value of k. Oh, floor. And I think if this doesn't work for k less than 1, though, does it? Because the floor is going to put it to 0, and that's certainly not the minimum. If k is greater than 1, I think it's fine. Where is it? Do I need to do +1? Or -1, maybe? Wait, no, k is a natural number, isn't it? Oh, why was I considering k less than 1? K is a natural number. Oops, it's c that can be irrational. Okay. So since k is a natural number, we're considering only positive k's. Starting with 1. And so this works for 1 in particular, because that would give us -1. Hey, Eller. Okay, so I think what I have now works. Yeah, it's the Greek letter. Actually, I keep on saying that. I should actually check. I'm pretty sure it's the Greek letter psi. Oh, that other one I was seeing is C? Oh my god, okay. I thought it was capital theta, but capital theta is like that. Where's psi? Okay. Oh, it's not going to show up right because my browser's cropped. Shoot. You're just going to have to trust me on it. It's psi, a Greek letter. Okay, so it's a trident. Okay, you know, you certainly can. For part B, we need the maximum element of each set, which I think we can just do the same thing as for the minimum, but chop off the minus sign. Do I still want floor? Yes, I still want floor. The set is bounded, give an upper bound. Also give a lower bound. How do you write in math terms? I mean, you already know LaTeX, right? You know, that's like 95% of the battle right there. Or you're like, more, you've gotten pretty decent with LaTeX now, right? Curious about the actual, like, language part of math? Like how you say things formally? I think the upper and lower bounds are the same thing. Yeah, okay, this is the part that's just an extension of the previous one, which I feel comfortable. So I might just say that I've figured out 3. Because we kind of discussed these two ones in the context of two, and I feel pretty comfortable with my understanding of them. I hope so. The language part, oh man, that's something where I feel like Zach, Stuckey, and Penn Center give you a much better answer. I have done very little formal writing for math. I would say that if you're just getting started, I would find math papers that are similar to what you're doing and copy that language and sentence structure. I think it's gonna be the easiest way to learn. I don't know if I can do it, but we could try 5. This is from Zach's real analysis class. So I'm just doing some like studying right now. For 5, it's going to be pretty challenging. I don't know if I can do it, but I want to try. No, we're building up to Epsilon-Delta proofs. We haven't done them yet, though. We've been doing Epsilon N proofs. Oh, hoo-hoo. I'll give you mod powers. So yeah, watch wherever you want to watch, but it's kind of fun to have a mod powers, you know? Oh my gosh. There we go. Add as moderator. Save. Okay. Now you have a nice little wrench by your name. Such cute emotes. Oh yeah, I don't know it. I never even played around with YouTube's emotes at all, so I barely ever watched a YouTube stream to be honest. So yeah, I'm just trying out the YouTube thing. I'm probably going to keep doing it for the foreseeable future, but it's something I just kind of like tried out on an impulse. Twitch will still be my primary thing. Oh man. Okay, so here we're given that A sub n approaches L. Hey, vegans! I'm doing good. How about you? I'm just working on some real analysis, like studying right now. Wait, oh no, we said it approaches A. Doing fine as well as solving math tasks. Nice, nice. And the question that I'm working on now is, does 1 over A sub n approach 1 over A? I think the answer is yes, just from my kind of impression of where the class has been going, but you need to actually show that. You almost look like a tinker? Oh yeah, you do. How is L less than epsilon if 1 over L is more than 1 over epsilon? I mean, if you're just saying in a vacuum, if you have the statement L, less than epsilon, these do imply both ways that 1 over L is greater than 1 over epsilon. Like in general, whenever you have an inequality, if you take the reciprocals, you flip the inequality. And that's because if if epsilon is a very big number, 1 over a very big number is a very small number. And so if L is also a small number, 1 over a small number is a very big number. So 1 over L has become more than 1 over epsilon. I guess maybe the easy example, if you do 2 is less than 1,000, that's, pretty easy to see that it's true. But then if you flip it, 1/2 is greater than 1 over 1,000. So it's just a rule you have to remember whenever you're working with inequalities, that if you take the reciprocal of each side, you have to flip the inequality. Divide both sides by L and epsilon? Yeah, you can do that too. Therefore, you also had an LCM. Oh, interesting. So you had in e to the 2i pi or Zach's real analysis class a few hours ago. As a group, we were working on problem 4. We didn't quite get there, but we got kind of close, and then Zach kind of clarified things afterward. And so I'm trying out 5, now knowing how 4 works, more or less, kind of. Oh, yeah. So we're able to prove that. For this one, I assume this one is also true. But it's apparently not a very easy proof. Oh, I didn't read the hint part. That's what Aller was referring to, but my explanation still was fine. Hey, Anders. I moved on to problem 5 now. I've only kind of just gotten started. One thing to consider is that bounding limit from above, as in what's the value of L less than epsilon. Therefore, it's a recursion have an exam. It's not standard enough technique. Oh, interesting. Oops, that's not. Man, we're using A. Try to trick you're not too sure about. Zach, Stu, here someone else could check it. Oh yeah, I mean, you can put it in chat too if you want, but if you'd rather keep it more secret, feel free to post it in my Discord, or I'm sure Zach wouldn't care if you put it in his. It's just probably better if you put it in Zach's because it's related to the class. But whatever works. Oh, it is? Oh, I see. Okay. Yeah, I want to at least see if I can come up with something that's vaguely okay. I'm not even sure what a good step here is, though. Which is not exactly what you may want to consider, so don't do this. Okay. I feel like the trick here is knowing what the first step is, and after that you can... It's maybe... I mean, there might be more tricks after that, but... Hmm. Wait. Is it cheating if we use number 4? Oh! What I wanted to do is... Never mind, no. What I was doing is absolutely wrong. I was thinking like, oh, well, what if we use our product thing that we just proved and do it for a sub n times 1 over a sub n squared? But of course, who knows what, you know, the 1 over part, we don't know what that would... We don't know that it will converge to 1 over a squared. So you want to develop the expression as much as you can to see how you need to control what bounds. So are you saying just like as an investigation, like develop the expression, like just trying to like manipulate it, I guess? Like if I got a common denominator for these two, I guess is what I would, is what would jump out to me. Okay. And we could also say that's equal to a sub n minus a over a sub n. And that would match with the a sub n minus a we have up here if we can somehow figure out where the a sub n come from. You have to go? All right, hoo-hoo. Thanks so much for coming by. I'll see you around. I'm looking for some kind of like plus something minus something like we were doing before. Could you... This is really off the walls, but if I started from this statement and I said that a sub n minus a over 1, whatever this 1 may be. Oh, you're saying triangle inequality? Or absolute... Actually, absolute value properties. Will you... I mean... Let's sort of back out to do triangle inequality there. Maybe thinking of some other... Absolute value behaves with respect to fractions. Oh, okay. You can distribute the absolute value bars, basically. So that gives us the a sub n minus a much more directly. But then it's not as simple as saying Oh, a times a sub n, it's just a scalar that's multiplying by epsilon, because a sub n is a sequence. So I guess that's where you have to get into bounding. This will control the other stuff. Okay. So we need to deal with this part. And if we know, since a sub n approaches a, then a, oops, that's wrong a. I was wondering why that looked wrong. Little a approaches a, then a sub n approaches a squared. So we could say this is less than or equal to an minus a over a squared. And that's just a scalar. Okay. Because you can multiply over it over to the epsilon. So we could say, I guess we were trying to work backwards. I don't know. I don't know how we set it up from the initial thing. I guess. So if we start with the thing that we actually know, a sub n minus a is less than, I'm going to take, well, we're going to multiply by a squared. So let's take a squared times epsilon. Much easier than what you did. I don't see what's wrong with it, at least, but hell if I know. So epsilon times an arbitrary scalar is still fine. So if I now divide both sides by a squared, I can follow my proof backwards, I think. Something wrong? Oh, wait. The limit isn't necessarily bound. Yeah, you're right, you're right. I think we use the same idea that Zach used for the first term in our expression. The same idea that Zach used, like, talking about for the product one where you do, oops. Like, what do we have? Like, a sub n minus a plus b sub n a minus b sub n a? Like, are you talking about this thing? Oh, yeah, we could do that, Anders. I'm not sure where it's going from there, but probably should do that. In W key faster, we'll welcome in. Radius length 5, height is 6. What is 3.14 times radius squared times height? For a cylinder? Diameter is 10, radius is 6. So it's only, so you have a cylinder, radius 5, height 6. And as you said, the equation for the volume is pi times r squared, which is 6, times, I'm sorry, radius 5. 5 squared times height 6. So I'd say that your answer for the first part is 150 pi or 471.24, depending on how you want to round. And for the second part of the question with diameter 10, well, diameter 10 is the same. Oh yeah, so I'm not sure what the last part of your thing means, but the volume of this right here is the volume of the cylinder. I hope that answers your question. No worries. And so I was misinterpreting what Suki was saying. For sufficiently large n, we know that, say, a sub n minus a is less than a over 2. That makes sense, yeah. Oh, yeah. Oh, wait, you said, or 3 over 2 also. And then do we triangle? Oh, sure, I forget what we... Do we triangle inequality this so we can manipulate our stuff? I don't think that doesn't feel right. You want a lower bound? I mean, okay. A sub n is greater than 1/2 a for the same large n? I keep on for some large n. Is that true? If this is your capital A, what if you're approaching from below? Well, obviously not the negative part because it's absolute values. Or did I not write down what you said right? This part here just doesn't make sense to me. Unless I'm focusing on the wrong part of what you guys are saying. Oh yeah, I guess you're right. It's 1/2 a. And then if a is coming from above, it's still okay. Okay, never mind. Just my brain is slowing down, I guess. About a less than 0. Let's find out. Well, it's not minus a, it's just a. Pretending that a is already negative. So 1/2 absolute value a is always up here. So if we're coming at it from above, we're in the clear. No? Well, we're less than. We're always less than. For some large n. But with the absolute value on the sequence, we should be okay. Yeah, okay, yeah, you're right. I was thinking like that, but... I mean, well, the same logic still applies for negative a, though. Matt, no absolute value. Yeah, it's still fine for absolute value, I think. Anders, are you trying to get me to think of something specific here? So I think what I drew before still works. And everything is absolute valued. Like maybe the first few terms are like, you know, oops. Going a little bit weird because they're negative, and then it... Okay. Sorry, I wasn't sure if you're like leading me to something or if you were actually like asking. Okay. Okay, so now that I convinced myself of the very like that probably pretty basic step, what's happening next? So I guess, are we maybe trying to invert this and use this at some spot? Or like at this spot in particular? Well, I know that we're gonna get like flipping. I mean, I understand like conceptually why. I'm still trying to see the proof when this actually occurs now. So if we take it from the, actually, let me take it one step further and separate the absolute values. Like you said to do earlier. So now 1 over a sub n is less than this. So this thing is less than. Oh, then the a's are going to cancel? I don't think I need those outside. And I don't think it'll affect anything either, because the expression is always positive. Definition converges properly, so you can cancel stuff and just let epsilon. Okay. I'm out of canvas. Don't stretch it, please. I really hope it doesn't stretch it when I do this. It stretches it when I do that. Go over to the right. So now okay, we've done it backwards, I guess. So are we? Okay, how to engineer this so we do it forwards? Well, our choice of epsilon, it's gonna be epsilon over 2, and then we're going to insert we're gonna say it's the same as having times a over a. No. We want epsilon. Never mind. Okay, well, the choice of epsilon is going to be 2 times epsilon, right? No. Why am I getting held up on the 2? Maybe what I'm doing is still fine. Well, but if we're going to end with less than epsilon, I don't feel like it's not okay. Maybe, okay, let's just ignore it. I assume it's okay. Wait, 1 and 2 in the denominator actually does need to be 2 epsilon, though. Okay, and then we rearrange it so it's absolute value a times two over a. Not like that. Okay, and then from here we use this thing is greater than this other step here. Without breaking the inequality, we can say that this new thing here is still less than epsilon. Because, I mean, even just like a sub n is greater than, or, using either of those, I guess. Okay. And now it's a bit more direct how you follow things backwards. I guess. I don't feel that good about it, but I feel like they've mostly followed it. Is this not right? This last part here? Like, the very last step was just, well, I don't think you're confused on that very last step. Was it using the inequality here? Or, it's like, it's the very last part was just doing the same manipulations in reverse, so I do feel a little weirded out by 2 over a. Like, oh, were you asking like this very last part from here to here? Or from there to there? Dark Aspect, thank you for the follow. Because I was kind of like hand waving it, but it was just these over here reversed. Oh. Ms. Monkey, thanks for the follow too. Nobody asked. Thank you for the follow too. Did something happen? Thank you guys all for following. Maybe it's just a good time to follow. I think we're done. I guess so, yeah. I'm a little sketched out that I started out with 2 epsilon and then I ended up with just epsilon. I guess that's fine. I guess this is the proof. I don't know. Well, hey, since there have been some new people who have been coming around, let me just do a little shout out to other math streamers that are on Twitch. As well as something that's happening in an hour and a half is Zach's real analysis class. If you go into e to the 2i pi stream in an hour and a half, I'm working on problems from that class right now. First column, we have a times 2 over a. Okay, yeah. Can we just cancel there? No, we don't want to cancel. I don't think, at least. Well, actually, when we were going forward, maybe it's okay. I mean, I thought we didn't want to cancel so we can do manipulations like this up here when we go forwards. Because it's like you need the 2 over a for the bounding part to make use of this fact over here. I think that's why you don't want to cancel. I mean, you could, I guess, but I think at this point in the scratch work, you're done. And you can go to the actual proof part. Or I think if you did do that, Anders, you'd be getting to the step that we started with all the way up here. So, I mean, I guess you're right, but I think for the sake of the scratch work, it's not necessary to take it that far. Because this is like the last like big idea. Oh, wait, so my entire interpretation that this first column was scratch work so we can figure out how we do the actual proof on the right. So you absolutely could, if you were to follow the scratch work all the way through, then yeah, you can end up with well, we don't know that it's less than epsilon. That's what we're trying to show, I guess. Yeah, I mean, you can cancel the a's if you want. I don't see the reason to, I guess. Because this entire thing is just scratch work, so we know what manipulations to do when we come over to do the actual proof up here. And so to do the actual proof, I multiply by a over a, and we get the same situation over here where we get a times 2 over a. That's where I thought the entire purpose of this was. Let me actually see what you put up in Zach's chat out of curiosity. Or in it's Vessi. Thank you for the follow. Yeah, so I guess I guess this is a question like the last real analysis class, where like which one of these halves is the proof, or you know, are they both proofs, or is only the side on the right a proof? Because I mean, I did the exact same work here, but just in one direction or the other. So I was doing this right side just to be more formal about it, because my impression is that the right side is the formal way to do it. But hell if I know. Okay, I don't know how much more math I have in me for the day, but let's at least take a look at number 6 here. Because I would think that we can just use you're the Hazel kind. That's fair enough. I'd rather be the Hazel kind. It makes more sense to me. But I don't know. So, I mean, 6 seems pretty simple if we're allowed to use what we proved in 4, and I don't see why we wouldn't be allowed to use it. Vegans, I think that's what we just did. In theory. I closed out of that paint thing without saving, so I've lost my what I had written, but it's Betsy. So these are questions. Okay, so I guess it my stream is normally me answering math questions from chat internet, like the title says. So I don't know why I explained that again, but it's sometimes difficult for me to actually like find questions out there on the internet, and there are most people in chat who have questions. So I'll do kind of random other like study problems, and so these are study problems from a real analysis class that's being taught live on Twitch, just kind of for fun, not for any sort of certification or anything. So these are questions that are real analysis. And anyone who's able to like watch along with the course, it's over on Zach's channel, or e to the 2i pi. There's 2 sections on Tuesdays and Thursdays. So there's going to be section 2 happening in an hour and 20 minutes, covering these same questions. I was in section 1. We didn't cover all the questions on the sheet though, so I was kind of going through and doing some of the other ones that we were able to cover during the actual class. Yeah, the base what's happening here is just like real analysis study. I probably should actually include something like that in the title, right? Real analysis study in the meantime. Sure. I still put it on the Twitch title, YouTube title. I'm too lazy. Yeah. So I looked at it in the Discord, and then I saw this whole conversation that took place. So I wasn't following it immediately, but let me bring it up. I guess... I don't know how I want to do this. Let me just get the image that you put and bring it over into Paint. Copy image, paste. Oh, hello. It's a little big. Yeah, please do. It's a really exciting thing that he's doing over on his channel. But yeah, like I said, maybe an hour and 20 minutes will be the next like go live thing. Okay, so this is what Andres put for question 5. Let me scroll this back up. Whenever a sub n approaches 1/a, yep. Okay. Let m be defined as inf of the sequence a sub n. And it does have an inf because we're talking about absolute value a sub n, and it converges. So it must have an infimum somewhere. Okay. Since a doesn't equal 0, then m doesn't equal 0. The infimum always exists for non-empty sets. What about... Oh, can the infimum be like negative infinity? I was imagining in my head like 1/n, or -1/n. We're like, oh, well, I guess it's a sequence. Well, if you got... I guess you got some function that did the opposite, where like it starts off high and then it goes down. Well, I know it's allowed to not be in the set, but what if the sequence just goes off to negative infinity? Is negative infinity a valid thing to call the infimum? Oh, okay, so I interpreted you too broadly when you said for a non-empty set. I thought you meant literally any non-empty set, but we're talking about the context of the absolute value of a sub n here. A convergent sequence a sub n. Delphic right might be worth arguing out. Okay, okay. Okay, yeah, that I'm comfortable with, I guess. That the infimum exists. So, but Stuki is saying if the infimum m is non-zero, using convergence to non-zero a. Oh, so just because a doesn't equal 0 doesn't mean the infimum, or it might require justification that if a doesn't equal 0, the infimum can't be 0. I don't know how you would prove that. I mean, it makes sense to me intuitively. I don't know how you would prove it though. Because I was trying to construct it. The only way I can think for the infimum to be 0, but when I'm talking about the absolute value of a sequence, is for it to, like, you know, approach 0. So I can't conceive of a different situation where you don't approach 0 but have a 0 infimum. But okay, I'm not the person who's qualified to argue that out, I guess, because I don't see the other side of it that easily. But if I were to just forge on with what Anders put, by how it's constructed, for all n belongs to natural numbers, a sub n is greater than or equal to m. Okay, yeah. If m is our infimum. There exists an n belongs to natural numbers such that for all n belongs to n, absolute value of a sub n minus a is less than absolute value of a times m times epsilon. So that's your choice of epsilon. They're all positive numbers, so I guess we're okay. If we're doing this, okay, yeah, you actually say that m is greater than 0. Good. That line is wrong? Well, if some m aren't 0, or okay, wait, no, but if we've accepted that m can't be 0 and you have an a sub n that is 0, just say it like it bounces off, doesn't that mean your infimum must be less than 0? If we're on board with m not equal 0? Or I guess you kind of stipulated that a sub n doesn't equal 0 in your definition of m. Could you? Wouldn't a sine function, like if you shifted a sine function up, wouldn't that hit 0 infinitely many times? Like you'd have to play around with the period. Or -1 to the n plus 1, I guess, is a simpler, is a more direct way. That doesn't converge, though. It does have to converge. Okay. Yeah. Okay. So yeah, it must be, if it converges, then, okay, yeah. Okay. And then, so you could kind of hand wave this by saying we're cutting off those finite, or not necessarily even hand waving, but it's a great emo. That's Alejandro's. So, okay, yeah, so I think this still works then, right? Because we can just choose our big N after whatever the last 0 is. Okay. And so is this... So then we kind of flashing back to the stuff that we had up here. It's kind of hard to see my cursor, isn't it? Going back to the stuff that we had up here. We're now picking it up by saying that it's less than this, which we showed up here. Or, I'm sorry. Yeah, because a sub n minus a is less than epsilon. Why am I confused again? What's actually happened here? No, I'm sorry. We're using this just on that. A sub n is greater than n. And so since a sub n is in the denominator, this entire thing is less than this. Okay. And then in the next step, we use this inequality now and plug it into this part. So the entire thing is now strictly less than that, which is just epsilon. And so if you take the first step less than the last step, you've shown that 1 over a sub n minus 1 over a is less than epsilon. Okay. That seems okay to me, but that means nearly nothing coming from me. Yeah, I guess you just need to flesh out oops. That part, but it still works, I guess. Okay. Well, nicely done. Okay, I'm kind of running out of math brain power. I feel like for 6, all you have to do is use what we proved in 4, but take b sub n equal a sub n. And there's your answer. Same with any power of a. Consider two sequences. I just want to see like what these other questions are. I don't know if I'm going to actually try and do them. But I'm just kind of curious to see what they're asking you to do. The symbols are getting crazier. By the end of the course, we're gonna be using like fish and like we're gonna be using like Twitch emotes, I guess. If lol sub n approaches kek w. You know, I was about to be surprised that there's the card symbols in LaTeX, but I guess you need them for probability problems. Can you say about the convergence of spade sub n? Oh, okay, so this is going to be the squeeze theorem. I don't know if I want to go through and try and actually like show this, but I recognize it says the squeeze theorem or the sandwich theorem, however you want to call it. I don't have enough brain power to actually try and go through with it right now. What kinds of monotone sequences converge? Try out some monotone sequences. Make a conjecture. Prove your conjecture. I would think a bounded monotone sequence converges, and an unbounded one doesn't. It's the difference between shooting off to infinity versus leveling off. I'm definitely not going to try and prove that right now, though. Okay, and this was capital Kisai, or Psi. My professor always said Kisai, so that's how I always see it. Or was it even? I don't remember anymore. It's considered Cauchy. For any epsilon greater than 0, there is an n such that if two indices a, b greater than n, not necessarily even consecutive, then, dude, I have no clue if... I would think they're convergent, but I guess maybe it's a one-directional implication. Which I certainly don't have an idea how you would do that right now. Ugh. Ugh. Okay, yeah, I am mathed out. Let me see if there's any other math streamers that I can recommend you guys to, because I need to, yeah, stretch. I mean, that, I always regret playing it right after I do math, but I do kind of want to do Baba as you. Oh, yeah, Jed, I saw Enigma post in Dan's Discord that the bot is down because I guess it's really cold where Enigma lives right now and they have to conserve power. Yeah, so I think actual education isn't going to stream for much longer, but if you want to keep watching math, you can always try going over there. I don't know how long he's going to keep going for, but you can certainly he is going and doing math at this moment though, so if you head over there, actually let me put it in the YouTube chat too. So if you still want to watch math, then there's that on Twitch at least. And I'm gonna switch over to Baba is you. I'm gonna end the YouTube stream here though, because I don't want to stream video games to this YouTube channel, and streaming it to two different YouTube channels is kind of hard to set up, or I didn't feel like it, so I'm just gonna cut the YouTube stream off here. Damie VTuber. All right, see ya, Anders. Thank you for your help today. I never heard of Damie VTuber, but there's some electrical engineering if anyone wants it. And yeah, thanks for just been watching on YouTube, as Jed said. I plan to stream on YouTube more. This was kind of like an impulse thing that I set up like last night, so hopefully be doing it more on YouTube as well. So thanks for everyone who's been tuning in on YouTube. I'm gonna cut off the YouTube stream now. I'm still gonna be going on Twitch with games. And yeah, all right, see you, YouTube.